Hi there, good day. Have you ever worried about the virtual keyword in C++ and you have wished that there would have been another way of doing that which will give you more control? Okay, there is a way and this is what I'm going to discuss it over here. So before that, let's understand few things. We have a class base and derived, which is derived from base, which has same function called function. There is a function called callFn which takes a base pointer. And in the main, I am creating two pointer, one of base, one of derived. I am calling the function to this should call base function, this should call derived function. And I'm again calling the function with this call fn with the by passing these pointers. So since in C++11 we use set pointer or unique pointer, so I decided to use that. And finally, we are just printing the size. So let's run this code and see what's the output. So you can see that this prints the base, this prints the derive. The things change over here because this call function prints the base, which is right, but this doesn't prints the derive as it happens over here. Okay, because it makes upcast into the base, and on the other hand the size of class is 1. So to solve particularly this kind of problem, there is something introduced by C++ called virtual. So what it does is that it actually corrects one thing, but it does many more things. So you can see that in this case also now a derived function gets called, okay, which is correct, and the size gets changed to 8 bytes because of the virtual table. Now to achieve something similar, there is a way you can do it by using template specialization. And why I'm saying that, because most of the time the base and derived class, there is no user relationship. So most of the developers, they just derive the class as if just to make reuse the functionality. So let's change the code. For that I'm I'll create a enumerator which will have two things derived. Okay, now this base class I'll make it a template class, which will, the template parameter is hierarchy. Okay, list everything as it is, and the base derived class will be again a template specialized class where it will not be named as derived but will derived as named as base only. And the tag, the hierarchy enum will decide whether it is a base class or derived class, and again it will be derived from base. So here you see I haven't changed the name of the class here, but what I achieved is the same thing what I was doing with the normal derivation. Here this represents a derived class, this represents a base class. Now this call function I also change it to a template function with a hierarchy tag, and here it will take again the base with the tag and do the calling, correct? Now in the main program, let me comment this cout for a while. What I'm trying to do is that I'm creating an instance of a base pointer. How I can do this is that making sure it's base. Okay, now I have to put one more here. Now again here also I have to do it like, put one more here, and we can make a derived instance by doing like this, make enum as derived. Is one more, same thing here. That's it. So it's the, let me see if it compiles. Yes. So this is the, we'll see the output later. This is the same thing what we had done earlier. Okay. So the normal derivation, which is using template specialization. Now when we see the output, this calls base function, which is correct. This called derived function, which is correct. Here you see it calls the base function, which is correct. It automatically calls the derived function, which is also correct. Okay, now if you see, just see the size of it. Let's say the size of since it's a template, we need to tell what is the, we need to create a type to come up with the size. Okay, and here we will do size of derived again with the base. Okay, now let's see the size. sorry, the virtual. Okay, I'm sorry, I forgot to remove this virtual, but it doesn't change the result over here. And now see the class size is 1 byte. Now there is another way of calling this. You can actually call this by specializing the template argument, which we need not give, is this base. Sorry. Now you can see again the result will be same. Okay, now you don't need to give these two inputs because it's automatically detected by compiler. Now there will be cases where you need to make sure that though you are calling a derived class, you need to get base class function call. In that case, what you need to do is that you have to give a template parameter like this and make sure that, it will make sure that it works. Now you can see that here the base function gets called. Okay, and again the size will remain 1. Now as you can see that we are getting almost similar hierarchy, similar code what we used to get with virtual, but there is a template syntax, but if you get used to it, it will never confuse you. It will actually increasing the functionality of base. This derived class, it actually can increase the functionality of base class in the way you want without getting into the difficult object-oriented relationship management. Okay, you can have even more than you can have base, derived, or much more than that. Okay, so why I said that we should avoid using this using virtual keyword, because when a function look when I'm calling a function like this, the programmer doesn't know which function will get called. Okay, the compiler which decide which function will get called, but at the same time this gives programmer much more flexibility and control on which function will get called, and the programmer always knows which function will get called when we call this function. So I guess that solves many of the problem which this virtual key thing has introduced. It's not a limitation of a virtual keyword, but maybe it's the limitation of a human being to understand and use it properly in a complicated scenario where thousands of lines of codes are written. So I hope you liked it. This is one of the way you may use. So thanks for watching and listening. Good day.